Thank you so very much, Selka, for the warm and wonderful introduction. I really appreciate it. And thank you, Brian and Ariane, for the invitation to come and speak with you today. Can you all hear me well? I think so, right? Okay. So, so I will be talking specifically about visualization, not so much only about networks, but in general about visualization. But I'll be focusing on network visualization a little bit as we move along. But I thought of actually focusing on certain constraints that I see as important for us to consider as we develop those artifacts. So basically, just to set up, is that, as Selka explained, I'm not a humanist so I'm a designer basically, although I worked in several areas and I collaborate with several people, so I appreciate your introduction. But I thought that it would be interesting to start with just few definitions, right? So we see with this burgeoning field a lot of terms being used, and I would like to perhaps make a distinction or show where those terms are being used in which communities. So I put here the 4 terms that are basically most commonly used, or we hear more often being spoken in the media even. And so the first 2 terms, information design and infographics, are mostly used within the design community and the journalistic community. And so, it is not new. We have been using this term for quite a while. And so information design, you would see a long existing associations in Europe and in South America. It's not common to see in North America, curiously enough, but it's like related to communication in roles or forms, or all sorts of ways in which we are trying to deliver information rather than persuading someone to do something like advertising, right? So that would not be called information design, for example. And then infographics, we see very often in the media or textbooks. So again, there is this very long history, and for a very long time as well, and I will be touching on a little bit on the history. On the other hand, we have other terms like information visualization and data visualization, which are new terms, and most of them we kind of see, I removed the slide from n-grams here, but we end up seeing more of these terms showing up in the literature, basically starting from the mid-80s, and that actually has to do with an NSF initiative on visualization that actually was in 1986, if I'm not mistaken. But in any case, I really like this definition by the seminal book that came out, by seminal computer scientists working on early on visualization and helping with this initiative. And it's called Reading Information Visualization Using Vision to Think, and which actually says that it's the use of computer-supported interactive visual representation of abstract data to amplify cognition. So even though we were trying to amplify cognition in the previous definition, right, here they are very specific about the medium, so they really talk about computer-supported, and they really talk about abstract. Whereas in information design and infographics, it doesn't necessarily have specifically to be that. And of course, we know that there are other disciplines working with visualizations throughout time, such as cartography and biology and many others, right? So I tend to prefer the term either information visualization or information design, because I like the idea of having the term information there. And even if we look at the term, the definition of information, and that is from the Oxford American Thesaurus. And so I very much like what it has there, which actually shows that there is an action of giving shape to something. And I think both the action, the acting upon something, as well as giving shape to it, I think it's is very informative. Sorry for the redundancy or the the loop there, but also if we look at other definitions, and here is a definition by Luciano Floridi, who is a philosopher of information at Oxford University in the UK, and he gives two definitions. One that he calls a weak definition, which is that it's a well-formed, meaningful data, and then he considers that a strong definition would then incorporate, conditions of truthfulness, right? And I'm going to go over some of his diagrams explaining this, but I think it's important for us to consider those two aspects as we move along, as we get more and more access to data, and we're trying to communicate information. So basically what you have in the screen right now is an information taxonomy by Floridi, and the paper is here. And so basically he considers that, so we have the data, so if it's not well formed, then it gets discarded. Once it is well formed, meaning that we have cleaned it, we have prepared it, we had sorted it in some way before we even start visualizing, right? And so then he already considers that as information. That goes to the weak definition of the information that he refers to. Obviously, we don't stop there when we are dealing with communicating it in any way. It can be through text, it can be through visuals, right? So here we are not even considering what is our output eventually, right? But eventually there are three types of information that he considers. Two types, semantic and environmental. Environmental, he considers information that exists out there in the nature, such as the rings in the tree or the ripples in the water, and so on and so forth, that we can actually gather information from that. And semantic is when there is, we are constructed, it has the human connected to that, and so it can be factual or instructional. For him, he considers factual when it is information about something, and instructional is information for something. And then once we move down, eventually information can be true information, or he actually divides into untrue information in two categories. One, when it's unintentional, untrue information, and the other is when it's intentionally deceiving information. And eventually, when we get out of that, we might get into knowledge. So the other diagram he proposed when looking at a paper in which he actually talks about visualization, and so the pipeline of actually the process by which we go about visualizing would be in that, let me try see if I can use this. Here it's actually the process that we would do for delivering a visual information, right? Because prior to that we're talking about any kind of information. And so here is basically what I will be focusing, and I'm not going to be discussing the process that we designers or others actually go about visualizing information, but I would like to discuss exactly, certain aspects of that. So this is another graph that actually done by the collaborator of this other paper that actually proposes a system for looking at how, and those are philosophers, so they are not actually visualization people, but how do we go about visualizing. And so from the process for encoding and both semantically and depending on the channels in terms of sensorial, right? If we're dealing with, tactile or visual auditory, or and so on and so forth, and then the process that one goes about decoding when one has to, on the other side, right, the receivers of this message. So basically, this is a caricature of that same process, right? So we, anyone, and I'm putting just an information designer because I am an information designer, but it doesn't matter, everything that we are doing is about, through a process that we go about encoding information, that we create something that at the other end of this equation that people have to decode. And this means important constraints and important facts to us, because basically we need some literacy of actually how to manipulate, how to encode, and how to communicate this data as those encoding it, right? The same time that we need, on the other hand, people who can actually understand and read those codes, right? So we're coming from humanity or linguistic, right? So it's basically, even if we read the same alphabet, if you don't read Portuguese, which is my native language, you wouldn't be able to decode it, right? Even though it's the same alphabet as we use in English. And so there are lots of layers to literacy, and I think that we need to pay attention to those literacies that involve not only cognition and perception, but involve certain structures and numeracy. Yeah?
You've got a plus way over on the left?
Yeah.
Is that intentionally nothing to the left of that, or?
Yeah, it's intentionally, it's really just a caricature, because this is not to say that we need people, or we obviously need questions and places where we are gathering the data, but it comes from, it's just a caricature to discuss these equations. So I put it on purpose, because once I showed a similar image and someone said, but that's not the process we go about. I said, yeah, it's not the process, it's just a caricature, right? So that we can talk about certain knowledge that we need in order to create these artifacts, and people on the other end also need the knowledge, right? So there is, I really believe that we need to work more on the literacy on both ends of this equation. So I hope it makes sense. And yeah, and sorry, I have to catch up on my thread of thought here. And basically, yeah, so there are several constraints, right? And so I would like to mention, for example, there are some studies actually looking at those constraints in terms of how, or even how we go about reading those graphs, right? And it's not intuitive, it's not that as we would encounter something and immediately understand what do they mean, right? So Steven Pinker, who is a linguist and also a philosopher, at Harvard, he actually, and a cognitive psychologist, he actually studied how the cognitive operations that we use or a person executes in the process of reading, specifically quantitative graphs. And he explains that actually we all use a general graph that we have learned to actually decode other things. So eventually we might have a general graph for bar graph. So if we see something that is not supposed to be a bar graph, but we would use that general graph. And so there are several ways in which we need to continue to study how to interpret those artifacts. And basically he concludes actually in the article that the efficiency would be provided to the extent that the schema allows for correspondence between the conceptual information and the visual attributes, and insofar as the visual attributes are encoded reliably, right? So that's why I very much, and I started with Floridi, because I think it's important to have that separation between true and untrue, but also it's not that people are always trying to deceive us. Eventually there might be some unintentional. And so basically basically what I will be discussing is basically these two areas, right? Yeah, it's not showing up, but it doesn't matter. I can use the thing here. So I'll be discussing this area in relation to this area, right? So I'm not going to be talking about how we go about producing them. So before I do that, I thought I would just give this little historical intermezzo here so that we could look, because we have been doing these representations, those information diagrams for a very long time, both informally and formally, as ways of communicating as well as ways of understanding and learning. And so those two images are on the left-hand side. You basically have there are several marginalia diagrams that we find, and so there are several medieval scholars from whom I have learned and discovered that actually, some of those diagrams made on the marginalia in order for people that were doing things to understand what was going on. Here we're looking at planetary diagrams, and basically sometimes those are later on incorporated into the main text, and sometimes not. And on the right-hand side, you actually have a table of the 10 commandments, which was pretty much for pedagogical purposes. And obviously all we see ourselves using those informally or formally because they mostly they help us with certain cognitive principles, and one of them is obviously increasing our working memory. So here I have two images of mnemonic devices, which basically are not supposed to be, external images as we are talking today, but actually internal systems, spatial systems. But in any case, there are several. There is a long history of mnemonic art, and most of mnemonic art actually uses the space to actually encode information so that we can use our understanding of real space to place memories in corners or palaces or hands or whatever it is. And so that's one of the reasons why we can use visual communication, because it's encoded spatially, basically. Right? But also, apart from increasing our working memory, they facilitate search and discovery because it's all simultaneously in front of us, so we are actually able to connect things more easily rather than going up and down on a sequential, on the sequence of a text, for example. And in addition to that, they support perceptual inference for the same exact reason, so that, they help us with providing models, right? Whether are models that of the world, like you have on the left the comparative cosmologies. So on the top you have actually the Ptolemaic system, and on the bottom you have Copernicus, and so we can actually basically see how the different models that actually people have devised throughout time, but also for future models like this drawing of the Darwin is representing. And finally, they can support data manipulation. But data manipulation is obviously much more new with computational, because it allows us, but eventually we see some data manipulation in the past, even with certain views. I would say that why not? It's some form of data manipulation. And but if we compare those certain structures of network genealogies, in here is a dichotomy, or with the recent internet online and interactive applications, we'll see that we're still using similar structures to encode data that has increased in complexity, but we still carry a lot from our past. This is another example in using certain ideas of genealogy. So here we have an early one of the three types devised by Bishop of Seville, and on the right hand side you have the again a recent application looking at the citation of papers in conferences, right? So obviously there are several differences, especially because we are able to interact with this data, but again, we are dealing with similar problems, right? It's just different kinds of complexities, and here I made a Google search for images and for data visualization, and the result brought several thousands of images, and these projects cover a really large ground, and with several producers, and from academia to industry to personal, for people, so from all corners of the world, and obviously, I mean, we are seeing this boom because there is a boom also in the access to data. So we basically, if I can find my mouse here, yeah, and but as an educator, basically I really ask myself, right, when I see these, right, and I see what are the pedagogical challenges that we face in terms of the literacy that I was talking about, right, and in view of this burgeoning practice. So I really question myself in terms of how we can move from being in awe of this boom of images that we see in front of us to understanding how to effectively communicate information, and how do we assess the efficiency of visualizations, and how do we learn from each other and experiences of success and failures, and furthermore, how do we go about educating present and future generations. And I would like to suggest that we need more analytical and theoretical practices on our field, and so I would like to discuss that. And obviously I'm not saying here that there are not efforts in this direction. There are obviously efforts, and we see a lot, especially in the computer science visualization community, and but I would like to point to an early effort in this direction that actually doesn't come from the visualization community, but it was written by Simon and Larkin, and basically questioning, when if the use of a diagram helps in solving problems, and if so, when, and if not, when not, right? And so basically what they did did a test with engineering students, and so they gave to a group a problem to solve that was only in the written format that you see on the left, and for the other group they also provided a diagram, and they studied how efficiently or how they solved the problem. So obviously the two representations, they differ. Basically, one is sequential, right? So if one has to look for the information, one has to keep going up and down on the list, and the other is visual, so it's simultaneously. And so they actually saw that the diagram facilitated the problem solving, and basically because it preserved explicitly the information that one needed for inference. It supported the perceptual inference, it facilitated recognition, and it facilitated search due of the spatial location of the information that needs to be together, rather than having to look for it over the list. And most important part for me is not that that is the case, right? It's actually that they warn that an image is not sufficient to guarantee. It's not that by including an image, it doesn't guarantee you that anyone would solve in their case a problem in a more efficient way. So, and that is for me the biggest question, right? Okay, we all know, and there's lots of studies showing that yes, those artifacts are cognitive artifacts, right? But when are they not? And I think that is a very important question. So, and then they say that efficiency, in their case, if they were looking for problem solving, would depend on how well the diagram takes advantage of these features, that is recognition, inference, and spatial location. And in other words, does the diagrammatic representation support efficient operations of search, recognition, inference? And furthermore, they suggest that the knowledge and ability to construct the most useful representations with which to solve the problem itself is part of the solving the problem. So it's really saying that there is not a given representation that we can actually plug in our data that actually will be efficient in communicating, even though there might be another case that in which it was efficient, right? I don't know if I'm making sense, okay? And so, having said that, I go back to our same diagram here, and basically to say that we it's really the human in the loop that I'm interested here. It's really, even if we use the machine for data acquisition or for automated representing whatever we need to pay attention to the human aspect and to being able to understand this bottom part, right, between the true information and the untrue information, and how we go about literacy for those of us constructing these visual artifacts, and for those of us reading or interpreting them. So basically, the first takeaway would be that whatever we do in terms of visual representations, they are human-centered artifacts, and we are in the center of that, both as doing them as well as receiving them. And so, due to that, there are several constraints, right? And not only cognitive, perceptual, I'll be talking a little bit about those, but also the dimensions of the medium. So we looked at papers or computers, so how many dimensions we have, and also the encodings, the different types of data, the types of knowledge that we bring with us prior to making those artifacts or prior to reading those artifacts, and even beliefs, right? There are several areas that actually constrain the way we read and make those objects. So I would like to, in terms of the cognitive constraints, right, I would like to use this example provided by Daniel Kahneman, who I believe you must be familiar, at least with the recent book, Thinking Fast and Thinking Slow. Here, these drawings are actually from the lecture he gave when he received the Nobel Prize. And so basically what he's talking here is that if I give you only drawing A, and if I ask you what you get out of, what kind of information can you infer from this drawing? Maybe I can ask you, yeah, what kind of information do you, if you look at drawing A, it's tall, right? So there is this immediate thing about height, right, that is very intuitive, it's fast, you don't have to, and so eventually you can even quickly infer, oh, maybe it's, whatever. If you learn about the height of one, you can quickly, right, without any effort, immediately tell me that, right? But if I actually gave you the same image, right, of drawing A, and rather asked you for the area, right, you really would have to make a huge effort, right? Because you would have to mentally move all these cubes and put them all together. In other words, create the image B, right? But in your mind, in order to infer for what it is. So basically, what he's talking here, right, is something that seems very simple, but I don't think so, right? And a lot of times we incur in these problems as designers, right, that we give the wrong image. We are trying to communicate something, but we are actually, rather than giving drawing A, I'm giving drawing B, or vice versa, and so on and so forth, right? So it's really important to understand that eventually, by the effort that we go about, which is the cognitive process, rather than the perceptual, which is the system one, which is more intuitive, more based on perception, and fast, and and parallel, and whereas the other one, which involves the effort, and it's cognitive and it's slow, but the important thing is that it's okay to have things that we would need people to have some effort, but effort, it has a gradation of, there are certain activities that are more or less effortful, right, and to what extent we are demanding, and there are obviously several constraints, and here a very basic constraint, which is color deficiency, that I often see relegated, and we were quickly discussing that yesterday, and but I don't want to dwell on that. But I basically want to talk about the fact that I see, when we are using those visualizations, and I'm mostly talking about visualization for communicating information, not for analyzing, it becomes really important to consider the communicative value. And from my studies, and I have been studying with a colleague, we are actually applying for a grant to study, but we have already come to some evidence that the general public tends to perceive visual representations, especially of scientific data, as the truth, regardless of whether or not people are claiming for the truth. And I think it's important, and that's what we're trying to study, really, to what extent our audience are interpreting visualizations as scientific evidence, right? And what are the consequences of actually leading readers to what can be considered false conclusions, even if we don't claim to be depicting any truth. And there are several disciplines that have developed a body of analytical research on this end, and that I can mention, at least coming from architecture, that architecture has developed, even though they are not dealing with truth, but at least they have developed a set of theoretical mechanisms to analyze more closely. And but other fields that are even in the creative side, even though I think information visualization is not this creative thing that people think that we do, but I think it's a systematic way of thinking and designing. But music also, right, is a discipline that actually has a very old way of looking systematically about those things. So as I was putting those slides together, I saw that there was this news about this this diagram here that was on Vox Media, so not to pick on them, but eventually Randy Crum wrote this article saying, that he was appalled to see that actually this having received such attention that it has, because basically it was encoded wrongly, because usually when we use a shape to encode information, we have to use the area rather than, because it's two-dimensional, it's an area, right? It's a shape rather than a line that is actually one-dimensional. And so basically the information here was encoded in a radius rather than in an area. So here is what he redid if we were to use an area. And so basically, if people were inferring information from here, they obviously were inferring very wrong information, right? And that is a fault not of whoever is receiving that. That's what I'm saying, the illiteracy from both ends, right? And basically what is actually pretty appalling is that he actually wrote the same, basically, I'm going to read because I think it's actually quite interesting. I cannot read from my screen here. This causes problem because readers often just look at the visuals without reading the actual numbers. They start with assumption that a visualization accurately represents the data. The Vox Media story and infographic already had over 12,000 shares on Facebook. I mean, 12,000 shares on Facebook, right? So I think it's a huge responsibility, so my takeaway too is that we really need to work on literacies, and I had a starting conversation, and I really think that we need to have visual 101 for everyone. We need to empower everyone with more tools for thinking visually, for producing visually, including numeracy and other sorts of literacies. So this is just one example of data. It doesn't matter the content there, but basically we are more and more facing, no matter where we're coming, our disciplines, and I think that's you as digital humanists are already familiar with, having to look at tables more than books or whatever, or as much as. And I think what I want to talk about it is that we need to be able to let go certain parts of this data, because if we want to capture every single aspect of the data sets that we encounter or that we collect ourselves, we end up with a crazy situation like this that is impossible to read, right, or understand anything at all. And for that, I would like to, I don't know if you're familiar with I'm certain you're familiar with the Argentinian writer Jorge Luis Borges, but he has one of his short stories called Funes, El Memorioso, and basically the story is of this guy called Funes who was unable to forget. Everything that he saw, he would remember in a very particular way. So every single leaf in every single tree that he ever encountered in his life was particular and was important because he remembered so in other words, he was unable to generalize, he was unable to categorize, he was unable to abstract. And for me, that's what it means, right? When we are unable to abstract or to generalize, we are actually not doing any good, right? And so we might need several types of representation rather than one, because in order to capture all these different facets and all these different patterns or properties or attributes that we have in our research, and there are certain areas that are very familiar, and again, sorry to bring architecture again, but architecture is one, right? So architectural buildings or cities are complex structures, are complex systems, and so basically we have been actually developing several types of representations, and that actually serves several purposes. And even more than that, they actually are made specifically for different audiences. So a drawing that we do for a plumber, is very different from the drawing that we do for the structural engineer, and so on and so forth. And sometimes not only one drawing, more than one, right? So we see that in information visualization. Obviously, more recently we see more, but there are some examples in the past, not many. So this is the one that I like to show because it's actually quite remarkable, and I'm sorry for those who were in the workshop yesterday because I also showed, but I think it is an amazing example, and I haven't seen many like these in the past. I don't know if Scott has encountered other examples like that, but basically we're looking here at the hierarchical way, using the metaphor of the tree, and quite literally in this case, and of the phylogenetic tree of birds. And so, but also what Fulbringer, I don't know if I'm saying correctly, did was actually he decided to look at this from the top, right? So this representation that you see here is coming from the middle section. What this allows us is actually now understand the clusters, right? So that we would be unable to understand, or it would take a much longer time to understand from this visualization. So obviously we are more familiar with this, even clustering visualization, given the expansion of network science, but I think it's actually important to remember that. And here it's just one example of recent application that actually deals with exactly the same issue. So in this visualization, the designer is Maurice Stefaner, who actually is depicting here a citation network of 400 journals, scientific journals, between 1997 and 2005. And so across the disciplines, so the color represents the disciplines, and each line is a journal, and or each circle is a journal. So basically, if we look at the top left, right, we would be able, in that one which is interactive, and we can interact and learn from interacting with this application, we would learn where the citations in a specific journal or specific category relates to each other. But if we would like to learn about the temporal, how it actually changed over time, that application, even if interactive, we wouldn't be able to get that information because it's not for that purpose. We would need to use the bottom one that actually is over time, and so on and so forth, right? But we also have seen this in many other disciplines, right? So in this particular case, we're looking at two navigational maps, right? So on the left is a Portland chart, which is basically for navigation. So all the details are on the coast, right? We don't need to learn any information inland. And obviously we know that, there are several maps that actually give that information, but that was not the purpose, right? Because we needed to land our ship in one of those, And the other is a similar approach, but to a road. So that's what we normally have here. So the third takeaway is that visualizations entail compromise, and we need to be okay with that. And the last point is basically that also some problems of the representations themselves, right? Some constraints and some limitations of the representations, and how we go about selecting them and interpreting them. So here we have 3 representations, and what do you think they represent? Each one of them, or all of them, or any thoughts?
There are 2 groups.
2 networks.
Red and blue.
And yeah.
And they don't interact very much.
And
They don't interact very much.
Yeah. From this one you get that, right? And what about this one? So you think there is more interaction here than here? Yeah. Exactly that. So all 3 representations are exactly the same, right? And all I was doing was actually using a different algorithm to plot these, right? And so all those representations that we see here are exactly the same data set. It's just a variation in the algorithm. So basically what I'm trying to say here, right, and we had a discussion a little bit yesterday during the workshop, is that, but eventually if I had chosen to my paper one of them, I would eventually if I show this, you would probably have inferred exactly what you did, right? Oh, there's not much interaction between them, right? But if I only had showed you this, it would have taken you more time to understand that. Or maybe it would not be that, right? That you would immediately live with, right? And so, furthermore, right, every time that we render these images, right, so this is the same algorithm, but two images rendered one after the other. Oh, let me render again, let me render. Every time is a different, slightly different image, right? And so, again, it's like all the same here, right? But it's not only representations that actually have limitations, also numbers. So if we say, okay, let's forget about representation, let's only use the numbers, again, there are problems with that, right? So I don't know how many of you are familiar with this. Is a Samuel's case in statistical measures, and Anscombe, it's called the Anscombe quartet. Basically what he did, he devised four data sets that actually had very similar statistical measures in terms of mean and regression coefficients and so on. So if someone would look only at these numbers, they would think, okay, these are all the same, right? But however, when you plot these, you see that they actually behave very differently, right? So, it's complicated. Life is not easy. So it's basically, we have to, kind of, pay attention to everything. So basically, the fourth takeaway is basically we need more graphical standards, especially for network, and especially because of the issues of, the different ways in which those data are being rendered and how we help others interpret besides our own interpretation and choice. So to finalize, I'll just talk one last talk about another constraint which refers to knowledge. And so basically, we carry with us certain knowledge or things that we believe that we should find because of one reason or another, that we are told that we know about, right? But we would be able to encounter certain things. And for that, I would like to tell the story of the unicorn, right? And this story I learned from a very nice little book of Umberto Eco called Serendipities, that I strongly recommend, in which he talks a lot about those stories of mistakes that end up different, like the discovery of America, for example. It's a huge mistake, right? And so, and among the many beautiful stories that he tells there, he tells the story of the unicorn. And so we all are familiar with all these depictions of the unicorn, and here we have this beautiful depiction at the tapestry at the Musée de Cluny, and there is the myth that the unicorn was this beautiful, white, gentle animal, only tamed by a virgin, and with the horn in the forehead. But curiously enough, no one had ever seen a unicorn in Europe, despite the many depictions as sculpture, paintings, and so on, right? But it was believed that indeed it existed, right? But one would find it in exotic lands, right? And so there goes Marco Polo to the east in 1271, and he actually encounters something there, and I'm going to read a quote from his diary. Scarcely smaller than elephants, they have the hair of a buffalo and feet like an elephant's. They have a single large black horn in the middle of the forehead. They have a head like a wild boar. They spend their time by preference wallowing in mud and slime. They are very ugly brutes to look at. They are not at all such as we describe them when we relate that they let themselves be captured by virgins, but clean contrary to our notions. Of course, he was talking about the rhinoceros, right? But he was led to believe that, he was supposed to encounter the unicorn, right, in the exotic lands. And eventually he encounters an animal that actually has the horn, which was the most peculiar thing of the characterization of the unicorn. So obviously, those are certain of the fallacies of knowledge. But we have other fallacies of knowledge that actually relate not only to things that we are blind of, but actually that we think we know too well, that we know too much. And I'm showing here the case. I don't know if you've ever played with this Mercator puzzle. It's really fun. But basically, it's actually showing that, Google decides to use the Mercator projection for the Google Maps. And we all understand why, because it's on a grid, it's programmatically, it's easier to construct it, right? But the Mercator projection was devised by Flemish cartographer in 1569 for the purpose of navigation, right? And so it highly distorts shape and area, right? And so I can guarantee you that Brazil is larger than Alaska, right? But so what happens is that now we, especially the younger generation, are really going to think that the world is the Google Maps, is the Mercator, is as provided by the Mercator projection. So it's the dangers that we have about certain, what became almost like a convention projection, right? So with that, I would like just to end and thank you and say that there is a little bit more in my book, but in terms of digital humanities, I co-chair a symposium on arts, humanities, and complex networks with Max Sick, who will be here in November, and Roger Malina, and so and we also put all our material available online for free, the videos of our talks, and so this year was our 5th event, and there is a Kindle book, and so but you can always go to the website and have a look at the videos and also apply for sending your work to our symposium. So I'd like again to thank you very much for having me, Ariane and Brian and Scala, for the wonderful introduction. Thank you for your attention.
Thank you.
I think I went a little bit.
That's fine.
Yeah.
We have time for questions.
Yes.
So back on the original Florida diagram, you still had the notion of, I kind of like your diagram with the plus and then not knowing that.
Okay.
His diagram doesn't have that. In the sense of the data, you've got data up there as if the data somehow or another is given. Whereas actually producing the data is another interpretive act. Building the sensor to create the first number, that already is interpretive act. And how you bring that into motion.
Yeah.
I mean, some people kind of refer to it as encoding stuff, but even when they talk about that, there's still this notion that, well, somehow have the data given to you or something.
Yeah.
Some notion that data is real in a way that the others are not.
Yeah, so if I understand correctly, right, so basically there is also this book, interesting book, right, Raw Data is an Oxymoron, right, so basically, I sort of agree with that. And obviously the way we collect data is already biasing the data that we have, right, and so either because of technology, because we don't have, even if we would like to collect more, or because of other factors. But in Floridi's understanding, right, is that even when you collect the data, let's say you're collecting through sensors, maybe there are some noise there that eventually you cannot be using that, so that would be discarded, right? So that's why he separates in that way. So I don't know if that answers the question. Or yeah.
Thank you. A lot of ground there. So I'm back on the pulley diagram, and you had said that a lot of people say that text is read chronologically, and an image a lot of pieces of information can be read simultaneously. And I think it's a little more complex than that, and there's been eye tracking experiments on both text and images, and there seems to be a human preference for top to bottom scanning for one thing, but of course the visual weight of information might, in a diagram, might influence that. But my other thought about, and similarly for text, people tend to scan text chunks, so the first part of text chunks like paragraphs. That's why we're advised to put the most important part of the information in the first part of the first sentence, etc. But my other thought about this was that when we say visual information, I think something like an image is quite different than a video. And when you were explaining this, my first thought was, this is the way to concretely explain why instructional videos, particularly informational videos on websites, particularly by university websites, are so irritating, is because you're basically dictating in an authoritarian manner the control of the flow of information, and you don't give the viewer or user the chance to choose what part to look at first.
Absolutely, I agree with everything. So first, that actually, yeah, it is more complex, but in any case, there is a difference in the ways in which we index data.
Yeah.
If we think that each word would be a data point, right? And so basically in the text, it is indexed by sequence, it is sequential. Even if we create some hierarchy there, like it is even 1, 2, 3, right? Or if we bold certain things, it's indexed sequentially, right? And the other is spatially, right? Yeah, there are several studies. There is Barbara Tversky has several articles in that regard in terms of instructional videos, and how difficult it is, because it's the same problem, because whatever is sequential, is temporal, right? And so basically it means that we have to keep whatever was there in the mind as we keep going. That's why when we learn how to read, it's so hard, right? Because we are learning the words, and we're trying to, that's why they make, when we're kids, right, all these kind of understanding readings, right? Because it's not easy, right, to keep in track of what we have read before, right? Because of our working memory, right? And exactly the same thing happens with videos. And so, yeah, it is also, she's a cognitive psychologist, and she's written actually extensively, so it's like, yeah, thank you.
Do you mind just saying her name again?
I'll write down so I can spell. Yeah, T for Texas, V for, let me only use food, right? For venison, E for, I don't it's getting hard. E for Edward, R for Robert, S for Sam, K for Kansas, and Y for yes. And her first name is Barbara. She used to be at Stanford, and I think now she's at Columbia. But she has several articles in it. But if you email me, I can point you. Yeah. Yes.
I could follow up on that, because the reference to the videos being authoritarian, I'd like to suggest a different example, and that's in the realm of architecture, and the notion of introducing someone to a building with a canned animation of a fly-through would be authoritarian in that sense. But at the same time, when you give somebody a three-dimensional model and put them down, and here's your 6-degree of freedom and control, they actually get very lost and don't go anywhere and give up.
Yeah.
And so there is some balance in there between trying to direct someone in a non-authoritative way, but in a helpful way to get through it. It's not quite clear how you draw that distinction, but there is that notion that when you put them into something that seems to have freedom, most anybody that goes to it then loses all track of what they're doing, or doesn't have any way of getting around it.
Yeah, and mostly I would say, right, because they lack a mental model of the plan, right? So it's very hard to navigate space. that you don't know because we don't have that mental model, right? So it's like when we go to a new city, right? Unless we really study and keep that mental model, we tend to kind of get lost, right? Because we need that mental model to navigate in space or in the screen, right? And so, but it's a great example, yeah. Okay.
Well, thank you very much.
Thank you.